Hi, I'm Tim Spann. I'm a developer advocate at StreamNative. Welcome to my talk here at Pulsar Summit Asia 2022. My talk is entitled Building Modern Data Streaming Apps. And let's get to it. I've been working with what I call the flippin' stack for a little while here. It's a mixture of Apache Flink, Apache Pulsar, Apache NiFi, great for different streaming and data applications. I've been working with different streaming and big data technologies and messaging for over 15 years, covering everything from Pulsar to Flink, Spark, NiFi, Big Data Cloud, MXNet, IoT, everything you could think of. And if you want to know more information, scan my QR code. Once a week, I have a newsletter coming out, covers a lot of cool stuff. Please check it out. What's all this about? I'm going to try to synthesize a way to build apps as easy as possible, and we'll walk you through it. Again, more info, scan away. What are we doing? Why? Well, there's a lot of data, lots of different data. And I tend to work with data all over the map. And it could be live aircraft data, it could be transit data, it could be weather data. A lot of data, but is it information? In the olden times, this could be some bunch of batches. They'd come in. Maybe we schedule them once a day, once a week. We'd get them. A bunch of people would look at them, get some different apps, pulling them apart, putting them together. And eventually we'd get something. Maybe store that in some data store. But, often something would slightly change, something be different. Couldn't react fast. Things would blow up in your face, and you'd be sit with nothing for that whole week. Well, in the modern times, we can't do that anymore. We've got real-time data. We've got the power of Apache Pulsar, and I want to get all these data streams as soon as each event comes into existence, and I want to join them together if it makes sense, build these fast streaming applications. Now, I'm going to be dealing with a lot of different data. We'll focus on a couple in a quick demo. We don't have too much time in this session, but it's train data, plane data, and automobiles. So we are looking at local weather conditions. The data we get tends to be XML. Sometimes it'll be JSON, sometimes RSS feeds, kind of XML. Mass transit status and alerts. Important, again, if we're traveling. Again, those tend to be XML, JSON, or RSS. I'm going to normalize as much data as possible into JSON. Easy to understand and read. All the tools out there understand it, and it maps very well to record type data. So we can synthesize a table, whether it's virtual in our mind or in a physical data store. Going to look at regional highway and tunnel data. This is often in GeoRSS, which is a specialized version of XML. Sometimes this data will be in protobuf, thanks to Google, and also JSON. Local social media, things like Twitter, that's still around by the time you see this, JSON. I'm also getting data off of planes, and I'm going to get that as JSON. But you can also get air quality from sensors or from other feeds. That tends to be JSON as well. We're going to try to monitor all these things that are happening at once and try to make it easy. We'll see if that happens. Before we get into the how, let's show you a little bit of demo just to show you what we can do here. Now, I've captured a lot of this in my GitHub. For this one in particular is the Pi80SB. This has source code, documentation, example images, and it walks you through a lot of what's going on. Now, this is a device I have attached to a Raspberry Pi to also connect to your computer, and a little antenna out my window. This may or may not be possible where you are. Could be blocked by the government, may not work depending on the type of transponders in the local planes. But for me, I can see what's going on with the local aircraft traffic. It includes the New York City, Philadelphia, New Jersey area. Pretty cool stuff. And as you can see, we do the standard things in Pulsar. Now, I'm going to create a topic, but we didn't have to. Nice thing is Pulsar is, as soon as I start pushing data to it, if I've got permission, it'll build that topic for me. No worrying about, let me design all these tables, topics beforehand. and set them up. Only thing you should really think about is schema. What are the fields that there are? What do they mean? Do I need them? Do I want to save them? And, you look at your raw data. For me, this is Python calling out to that antenna. We get that data and we could parse it out. And what I do is have a function, which I have documented here. And that takes all this data coming through, cleans it up so that it's in a nice format so we could do things like Spark SQL against it. Spark is a nice way to do that, or Flink SQL. Again, Flink SQL is a nice way to do this. Okay, so all this is documented in there. So I'm going to show you this in the demo. So we've connected to our Flink cluster here using the Flink SQL client. We could do this in an app. We could do this in a third-party streaming app. Lots of different ways to collect to Flink SQL. I'm doing it the easiest. This is just running on my laptop just to keep it easy. Create that catalog, use that catalog, turn on some options in case I want to show historic data. Look at all my databases. These are tenants and namespaces combined here. I'm going to use the standard public default. Yeah, I know. And we have a bunch of data here. I've got it for aircraft. Get that raw data we saw before, air quality, which I break down as well. Tons of different ones, transit. We're going to take a look at aircraft. And to see what we could do here, I've got an interesting one where I do some maxes and mins and a group by here. And we'll run that query. But let's get some data. So I've got a Raspberry Pi, like I mentioned. I'm connected to it. I'm going to run that little app. And this is finding a lot of air traffic. I'm guessing this time of night on the weekend in my area is busy. So we're going to get a bunch of data here. I've also got similar queries here for the transit data. But let's take a look. We'll also show you how I get the weather data as part of NiFi. Let's see if that Flink app is running, and it seems like it is. I'm collecting data, doing an aggregate on it. We see we've already gotten 700 records. Maybe I'll send too much here. This is a laptop. But let's take a look. Looks like I've got the 4 pages of data ready. And these are all unique because when we did that query, if we take a look at that, the code for that query here for aircraft, we are grouping by the flight, and the hex here is, if you look up here for the description of all these fields, is the identifier for that plane. So we got the plane and its flight as specific identifications here. So we could look at one and we could see how many rows of data we have for it. Name of the plane, if we're interested, speed, altitude. That's pretty cool stuff. And that keeps updating if there's a new record. But these are group bys, and you saw how easy it was to do this. This is just pretty amazing. You could do this as these events are happening, and just as more come in, that happens. Pretty easy, but I could see everything going on in this. Makes it pretty straightforward. If I look at this is the public available record for my little antenna. I broadcast that out so other people could get information, what's going on in the real life traffic here. And then I can also show this in my own little dashboard, and I'll show you the technology behind this, but this is a WebSocket call to Pulsar on that same data. And we can stop this query here, and we'll maybe run just a little bit more data there. As you can see, the higher those numbers are, that means the more planes are out there. I tried to show it all, but then my screen was just really badly littered there with way too much information. You don't really need that. So we canceled this one. We can look at some other ones, but let's look at weather. Weather, depending on where you are, is usually available in some weird formats. And to get that in any time of real-time fashion, you might have to pay money. For us over here in the US, NOAA provides a feed. updated every 15 minutes for the whole country. I think they intend for you to manually download this big zip file and unzip it. But with the power of NiFi, I can automate all of that. I'll just run that once, and you can see that unzipping, pulling out just the ones I want, and then we convert that XML into a more pretty JSON, easier to work with, easier to put through the system, easy to add schema. And as you see here, data's coming in pretty quickly. I've already have a few hundred rows here. We'll look at the data provenance, make sure everything looks good here. Weather, different airports, and I could actually look at the data while it's in flight. You can see we've converted this to JSON. Some of the temperatures here, Celsius 14. A little chilly for this time of year, but you know, it is starting to be fall. So we've got like 2,000 records there. So that's something if we went into Flink, we could see those tables. And that's weather. So we can look here. What does weather data look like? What's in that topic? Okay, I didn't put in a schema for this one. Jesus, should run a schema on that. And that's what I often use for Flink. What about this transit data we were mentioning? I've got a high-speed connect to some local traffic here that gives me that bridge data and a bunch of others. But that's GORSS. Again, not my favorite format. Fortunately, NiFi will convert that right to JSON, and you see a bunch of records come in, but it's one file with a ton of JSON records. I don't really want to store that. I'd rather do that individually. Then I'm going to add a timestamp, a unique ID, parse out that Latin long, send that data out here, and I have the capture the data separate from that data being processed. And if you look here, we've already got 90,000 records. I'm not going to send all of them in, just a couple hundred. And just by refreshing, you'll see I've already processed nearly 1,000 before I stop things here. So that 3,000, wow, data's going fast considering this is all on my laptop. Now that went into the transcom here topic. And if we look, I have a function here that takes the transcom data in and parses that out to a cleaner transit format. And we could go into the source code, but that's just suffice to say a function's running, and that will give us that back, this transit data. And we could do a query on that. We look at here, I've got a bunch of queries already defined, so you could take a look. And this is, I'm running the latest connector here for Flink 115. And we're going to run this query. Let's make sure that's getting distributed out to our Flink cluster, and we can see that it is starting to power up here. It is doing a pretty easy one here. If we take a look, it's hitting Pulsar, public default transit. It's got a couple of fields we asked for, and we'll see that it's coming in already, and we already have 1,100 pages of data. So there's a lot. So if you embedded this in a Scala, Java, or Python app, you could do something. We could also in here do an insert into another topic or into another Flink catalog, which could be Kudu, HBase. There's a ton of them out there for Flink. As you can see here, the data is just coming in a massive stream. We have a lot of construction in the area, so there's a lot of different data here. So that's just coming in really quick, just to give you an idea what we could do here very easily. We could also run a little server for transit data. If I could find where I did that. Too many screens here. I might have closed that one already. That's what happens when you try to run too much here. So we have that data. It's coming through. Let's get back into the slides. And if we have time at the end, we'll go back and show a little more demo. Again, here's a nice article on the flip stack. And I like to, you know, remind people that Pulsar is more than just this individual platform. There's a lot of different ways to interact with it. whether it's through the different protocols, functions, which you just used, IO to get things in and out, Flink, NiFi, Spark, or your own client apps, Pulsar SQL from our Trino friends, data offloaders. It is a big, happy ecosystem. For that plain data we saw, we got a Python app, pulls it off that device, pushes it into a raw topic. We've got a Java function for Pulsar that is cleaning that up, adding a schema, enriching it, and pushing that to the aircraft topic, which we can query easily in Flink, as you saw. And we could also do similar things if, say, a Spring Boot app, which we now have a beta library that should be in production in the next couple of weeks, that will let you easily push your data into Pulsar, and that's pulling in some local RSS feeds, telling me the quality of air. Also have a NiFi app that looks at a different stream of data. Both push into Pulsar. Function cleans it up, parses it out, whether it's PM2.5, PM10, or ozone analysis of air quality, and makes it available for Spark and Flink and Delta Lake. You get the idea. We saw that Transcom REST data coming into NiFi, gets pushed into Pulsar topics, and very easy for Flink to interact with that. Now, we saw in the beginning, we had NiFi doing the big ingest. There is a great connector out there that David wrote. David is speaking as well. Definitely check out his sessions. He's got some really cool talks out there. But this is supported by both Cloudera and StreamNative. This open source connector works really great. And as you saw, we were using that in the demo. Very easy to consume from Pulsar with NiFi or publish. And you get it out in raw format if that's what your data looks like. If it's tabular, you could use NiFi records, which makes it very easy to convert to something else, run local SQL on it, do a lot of cool stuff. Shout out to Apache Calcite again. NiFi has this data lineage, shows you the provenance of what's going on with your data, size, a unique ID, when it first started, every step, every type of modification, and you could store this lineage. This, again, could be a massive stream of data that you could push somewhere like Pulsar. So easy to produce data there. Now, we were showing you some of that transit. You know, what's nice is having this infinite message bus. So if I decide to push it in with Pulsar or Kafka, AMQP, MQTT, WebSockets, very easy to do. And we can partition or not partition it. It's not as critical as with Kafka. And you've got whether you could do streaming or messaging, depends on how you want to read it. That's great. You don't have to decide that when you're getting data in, and different users and apps can consume the data differently. Streaming like Kafka or messaging like a word queue, great options out there. I use shared a lot for display stuff. So there's a lot of cool features in Pulsar. Probably shouldn't have to spend too much time on this. You came to Pulsar Summit. I hope you like Pulsar. But there's a lot of awesome features in Pulsar. To me, this one is unsung and not talked about enough. Schema registry is so much easier than the ones I've had to use before. It is just there. And if I push something into it, it's very easy for me to define a schema by just creating a Java bean, push that into a topic. Now I've got a schema. That's great. It supports Avro, Protobuf, JSON. It just works. It is very easy to use, and it makes the data available to query in Trino, Flink SQL, Spark SQL very easily. Highly recommend if your data looks like a table row, if it's in JSON or Avro or Protobuf, use the schema. It'll make your life a lot better. Gives you some level of data quality, data validation. This is step one, man. Get a schema, use it. MQTT, great library. Very often you've got some little embedded device. It might be hard-coded to only use MQTT. Well, turn on MOP, and I could just act as a broker there. Again, a lot of people have legacy Kafka apps. We could support those. Keep those existing old apps and libraries, things you're using, and just modernize to Pulsar. This is a new source out there. This one is great. Can pull data out of Hootie, Delta Lake, Iceberg, all the modern lake houses right into Pulsar, distribute that data to other apps. Very easy to do. I've done this one, and this is available in some of my source code. Really easy to sync any of these streams right to Delta Lake. Makes for a great way to populate those massive lake houses, do that at scale, and having it in Delta Lake has a lot of great features. If you haven't seen that yet, check it out. Same goes for Iceberg and Hootie, other great Apache projects. Now we want to do some ETL streaming with Apache Spark. Spark is really easy to connect to Pulsar. Connect to that service URL and the admin URL. Again, you need them both in Pulsar, one for the messages and one for the admin REST stuff, which comes up a lot. You need that metadata. Put in your topic. Again, that persistent out there, you don't have to have it if your thing's not persistent, but 99% of the time we have persistent topics. Put that out there. Put out your tenant, put out your namespace, put out your topic. Ready to go. We can take a look at that schema. Again, use the schema. Otherwise, maybe you have to manually parse it. There's extra work there. People might not decide on the same types or if things are nullable or not. You don't want people guessing. I mean, they might not be the right guess. And we could just select all the fields out of there. And very easy to write this to the console or to a file. Again, lots of different apps you could do this. Maybe join it with other streams of data, or send this to some data store, another stream. Very easy to do with Spark. And we could do the same thing if we want to write to Parquet files. Again, another option. Or you could use Delta Lake. We often want to enrich, add machine learning, whether it's just classification or maybe you're training something. Or you might just want to route your data. Pulsar functions are the way to go. They are great for microservices. Very easy to maintain and test. 3 good options for language. A couple more are coming. I think someone might have a talk about using SQL there, which is pretty awesome. Again, maintain your source code. It's not really directly connected. You connect through topics. That's nice. Independently deployable. Deploy them where you want. I'm writing these myself. A couple people can develop a lot of these functions. Very reusable. Great way for communicating. Great way for enhancing your messages. Very easy to use something like function mesh to put these together in a, dynamic pipeline. Very nice. It is not for every use case. Remember, Flink, Spark, great places to do a lot of work. You could use these functions as part of an enterprise AI, and I've got a great article in there on how you could use Pulsar as part of your ML classification. Obviously, you could do things like convert. You could run machine learning, whether it's a local library or maybe you make a REST or other call out to a classification server. Got that logging and auditing in there. Easy to parse your data, split things out, convert. Lots of cool stuff you could do. Keep adding more topics dynamically later. And then the output you could define on the fly. So if I get a new type of data in, I can look at it and decide this should go into a new topic and send it to the topic, building it on the fly or using the admin URL, and clearly execute your ML. This is an example Pulsar function here. We're taking a string in, nothing's coming out because we are going to define our own topic to put this out on. And we're pulling that out of a configuration so it could change very easily. And this one, we're just adding exclamation point at the end. Silly example, but works. This is one in Python. This is one of mine. I take in a bunch of text and just returning it with an ID added. Pretty simple stuff, but you could do a lot in there. Now we want to do some kind of continuous analytics. Flink SQL is the place to go. There's a very robust connector there. We just updated that. I used that today in the demo. It's very nice. These things run as jobs. You get that nice way to view them either in a dashboard, or you can push that into your enterprise system or through the different REST endpoints or logs or wherever you like to do that. You can do things like maxes and mins and averages and windows and as much SQL as you ever want, but on real data as it comes in event by event by event. So that might be enough. You might have done everything you need. But you might need some apps, and Java and Python are a really good way to do that. And, you know, you could wrap your app, use some Flink SQL in there. Something happened weird. Okay, there's the output if we're running a Spring app. Spring, like I said, we've got that new library that'll be official very soon. It is really easy. Again, here we have setting those schema, and the schema just says, I want the JSON one on this Java bean. Send a new message. We just send an instance of that bean. Tell it that's what the key is. Send, we get a message ID back. So you can do with what you want with it. And then if we want to do a listener, even easier, give it a subscription name and type. Say what the schema is, point to a topic. Boom, I get the data, can do with what I want with it. Very easy to write those apps. Configuration, super easy. Here I'm connecting to my StreamNative cloud. I'm using OAuth. Got my link to my OAuth parameters. Got a couple things I'm setting on the producer, like the topic name and a producer name. Boom, ready to go. I could also use the new reactive framework for Spring. That one's pretty cool too. Set a couple of parameters. Boom, you're ready to go. This is super fast. If you're a fan of reactive frameworks, definitely check it out. We can build dashboards, and I showed you one, and this is just simple web sockets. I connect to that topic, give it a subscription, get the data back as web sockets. I'm using data tables. That's a jQuery library to display it. Very easy. Ton of different ways you can map this to other HTML. Very easy to get that WebSocket data and display it on your screen. It couldn't be much easier. And you could also send that data to a map. And I've got an example in the transit one where I'm taking transit points using that same WebSocket logic. Thanks, David. And you could see that on a live map. Pretty easy to do. We could also get back that data inside of Flink SQL dashboards, but you get the idea. We got a ton of code for you. I'll give you the NiFi flow, the SQL, the Python, the Java, HTML, all that's available in these GitHub libraries and a couple other examples. Some of the examples on Spring. Some of these I walk through step-by-step different ways you could do this. Couple of articles to show you a little more background on how to build these apps. I've been Tim Spann. I think I have a couple minutes, so I'm going to go back into the demo. But definitely contact me if you have some ideas or some questions or some demos that you have a good idea. If you have a data feed and it's openly available, I would definitely like to try to grab that and push that into Pulsar. That's kind of my hobby. So if you got some of them, definitely point them my way. I am interested in writing that app because it's easy. So in NiFi, wow, get a lot of data there. So I can easily push this to the transit data, and that's the one showing up here. We haven't gotten any data in a couple of minutes. So I could refresh that, see if we're getting more. Maybe we just need to send some more. Remember, we had this app down here. I shut it down because it very easily builds up. And then before you know it, my machine is crashing because they've got too much data. But if you look here, I highlight one. It is changing. We're getting like a couple of rows a second here off of some local planes. I'm going to stop this so we don't get more data. And it finally caught up, so it stopped. But you could see if we want to search by, order it by flight, you could see we get records every minute or so from each individual flight, saying where it is, what's the flight number. See, like these are commercial flights because you could see the number there and the identifier for the plane, how fast they're going in miles per hour, what's their altitude. Pretty cool information to be able to see that live as it comes in. And if I wanted to run Flink SQL over it, I could do that as well. If we look through the transit data, I also have a couple other transit feeds that I didn't show you here. Works very similarly. Work about the same. So we've got bus data, rail data, light rail data, and I've been running this for a little while. So there's a bunch of data coming through the system. Again, RSS, convert it into JSON. I could have wrote some SQL on here that maybe took less fields out as part of the select clause, or did a where clause to limit it. Maybe however I want to do it, then split it out. Then I also look for certain events of interest. And if I get them and I see a problem, I can send a Slack message, which is kind of cool. And then when I'm getting here, I'm going to push that into Pulsar. And as you see here, we've had a bunch recently coming through. I'm going to send a couple more just so we could see that come through. I'm going to send some rail data. I don't know how much rail data there is, but there's a couple. And we could look at the data provenance. What this one came in this minute. Anything interested in this one? Lots of interesting data. And we could take a look. That'll pop up over here. No, this is aircraft data. We got to look at the transit. So we could do a query on the transit data. Very easy to go in here. And we could take a look at that transit data again. That'll launch that app real time. And very easy way to show you that. We look into transit, you can see a bunch of different queries I was doing, looking at the clean data. So what I had that function do is take the data, convert it into a clean version with a nice schema here for those fields that I like, as well as taking every record and putting it into transit. So I've got one place to query it. But as you see here with Flink SQL, I could union those all together very easily. Or I could join different data. I could join, well, that's a weird looking join there. But you could join different tables together very easily as long as they have something in common that makes sense. But yeah, you could do windows of data if we want. We did the light rail. We could do buses, probably have more going on at this time of day. Let me do a bus. And there's maybe 20 records. So let's look at, as you see, data is still coming in from the Transcom because there was a lot of that data. So if we want to look at all the tables, I'm going to describe the, say the bus data. I'm going to look at bus clean here. Okay, let's look at the description, the pub date, title, TS from New Jersey bus clean. And that's my local cleaned up data. And we'll be able to see that. We'll see that it launched over here. Always like to watch. There's no reason to wait for that to come in. But there's the fields I talked about. Any calculations there. It is just getting going now. Oh, we got some data here. Let's get to the most recent. And we could see this happened. For me, this is recent data. This just happened half hour ago. Oh, they don't have a bus. That's not cool, man. Somebody's waiting for a bus, trying to go to the mall. And you can see different announcements here on the bus as we're looking at the bus data. Detour, important information. You wanted to take this data, the rail data. So at any point you push this to a mobile app and say, hey, I want to go this place or that place. What's the best route? What's up to date? And I can look at this transit data. I could look at plane data. I could look at weather data. I could look at social media to know, hey, something's going on in that area. Maybe don't want to go there. Lots of different streams of data together make for applications. You might want to be able to do things on the fly as they happen. Here in the transit data, I could send that to a map. So you could see that easily. Again, push that to a phone. And I could say, hey, I don't want to, if I'm going to go over here, I better not take the train, better take the bus. And I'm looking at some other transportation data as well as this GTFS format. So we'll get even more data into this one topic. to make a very pleasant experience for anyone who wants to use that type of app. Again, once you can control the data at scale in real time, it's very easy to build these modern data streaming apps, whether you want to do it in Java and Spring or Python, or do it with just some simple SQL, or possibly do it all in NiFi, not having to write much code at all. Lots of ways to build modern data streaming applications. I hope you enjoyed my talk. Please join me in my other talk on Python and Pulsar. Thanks for joining me today. I hope you enjoy the rest of the conference. It was great doing this talk. Thank you.